Okay, grade 12. Let us look at this one. So I will stop here for now and then I will continue later on. Look at this one. So I'll do this video. That's what I'm trying to say, and then I will send it to you. So we are looking at a graph that is called a stationary point of inflation. So this graph, it's a situation where this graph can only happen if you have. So let me wipe my camera a little bit. Ish. This graph can only happen if you have one stationary point and then this one stationary point is, let me say, is the same as the point of inflation. So what sometimes can happen is that when you are finding the stationary point, you can get one stationary point which is the same as the point of inflation. So you will see what I'm trying to say in a moment. Before we can continue, look at this one. So if you are looking at this graph, it's an original cubic graph. So with this one, the value of A is 1. So I'll just show you the shape here. So this one is the same as y is equal to, so I have this and then I put cubed there. And then x hasn't shifted, I will put minus 1 there. I mean minus 0 or plus 0. It's my choice. Let me put plus 0 and then plus 0. So which means what I'm trying to say is this. So sometimes a cubic function can be written in this form: a x plus p all cubed plus q. Okay. So where p and q, where these two, where p and q represent the stationary point. At the same time, they represent the point of inflation. The point of inflation. So you will see what I'm trying to say in a moment. So which means this graph, now when I'm drawing this graph, it will do this because the value of A is positive, which means it should start by going up like this. But then it turns, and then where it turns like this point is also a point where the graph changes concavity. So which means it also goes up like this. Okay, because the turning point and the stationary point are the same. So which means this one will be like this. This will be like this. Okay, so it passes here at an origin. So meaning this one, the second one, okay, which is this one. So this one, let me draw a Cartesian plane. So which means this one, because the value of A is negative, which means it will start by decreasing. So which means it will go down like this. So which means this one will be like this. It should start by going down. It will be like this. Where it's turning is also a station, a point of inflation. So it should also change the concavity. So you have this. Okay. So you have this. So this thing that I'm looking at is similar to this. Look here, it's a similar thing. Remember with the cubic, so I mean the quadratic one or the parabola, this one is facing down. So this one is facing up. The original graphs, can you see? So I can affect them by shifting them up or down. Shifting them up or down. This is the form. This is the same form. This one is a squared plus q. Can you see? So meaning this graph, for example, if I want to shift it 1 unit up and 1 unit down, so which means you will have something like this. Okay. So when I'm shifting it 1 unit, let me say I'm shifting it 1 unit to the right. Okay, so if it's to the right here, I'll have to minus, and then I'm shifting it 1 unit down. Also here I have to minus, so which means this one will be like this. So it will, remember, for me to get the shifts, I'll say x minus 1 equal to 0. So which means x is equal to 1. So which means here it stands at 1, where yx is 1. So which means this graph will be like this. Okay, it will be like this. Okay, should pass through here. Yeah, so it will be like this. So shifting the graph up or down, this form, it comes from here. Now it will be like this. Okay, shifting the graph up or down, left or right, so this form will be affected. So what I'm trying to say, also I can use this form. So I want to shift this one 1 unit up and 2 units to the left now. So which means I have y is equal to, we put x. So I'm shifting it 2 units this side. I'm shifting it 2 units this side. So this side basically is a negative direction. So when I'm putting it here, I'll put plus 2. So I'm shifting it 2 units that side and maybe 1 unit up, 1 unit up. Yeah, 1 unit. So when I'm shifting it 1 unit, which means I'll add plus here. So which means the turning point now will be at, if it's plus 2 here, it will be negative 2. And then this one doesn't change, it's 1. Okay. So I'm shifting it, yeah, I'm shifting it 2 units to the left and 1 unit up. So which means now it will be somewhere around here. So let me use red. So and extend a little bit. So which means this one will be somewhere around here. Okay. Apologies for the diagram. So where the turning point is negative 2 and 1, negative 2 and 1. So this is how we shift the original graphs. Okay. So basically what I'm trying to say with this is that even these ones can be shifted. So for example, this one I can shift it to have an equation that says y equal to maybe there's 1 then, and then there's x, and then there's cubed there. I can shift it 3 units to the right and then 2 units up. Okay, so which means when I'm shifting this one, you will have something like this. So remember the original passes here, and original is this one. So which means now the new stationary point here. So the stationary point here, stationary point, this is stationary point. It will say if x is negative, I'm shifting negative, I'm shifting to the left actually. I'm shifting to the right. Okay, so which means the stationary point is, will say I'm shifting to the right, don't forget. So I will take this negative 3, when it comes here it will be positive 3, and then the value of y in this case is 2. So which means this point will be turning somewhere around here. So you'll have something like this. Yeah, so this point is a point of the stationary point where the graph turns. At the same time is where the graph changes concavity. So it's 3 and 2. So you have that. Okay, so what I'm trying to say here, please, if you didn't understand what I'm saying, you must understand this one. Look at this one. We can give you an equation like this. Look at this one. I'm giving you an equation y equal to x minus 1 all cubed minus 1. Okay, and I say electricity just went. Okay, it's back now. Okay, it's back. And this one, look at this one. I say this graph, ne? If you didn't understand what I'm saying, just try to understand this. For example, here. So I want to sketch this graph. So when I'm sketching this graph, I want to show the stationary point. The stationary point. And then I also show the point of inflation. And then I also show the x-intercepts. The x-intercept. And I also show the y-intercept. Okay, the y-intercept. So if you didn't understand what I was trying to say, try and understand what I'm saying here. Look at this one. I can say this. So with this equation, I can multiply it out. So remember, this equation is the same as x minus 1 times x minus 1 times x minus 1 minus 1. Okay, yeah, because there are three of these. So when we are multiplying this, you will have something like this. So I can say x times x is x squared. X times negative 1 is negative x. X times negative 1 is negative x. 1 times 1 is positive 1. So I have multiplied the 2. And then I'm left with this. So which means here I have y equal to maybe x squared minus 2x plus 1. Yeah. Into x minus 1 minus 1. Then now I'll have to multiply this one here. Multiply this one there. Multiply this one here. Again, with this one, I have to multiply it here. I multiply it here. I multiply it here. Okay. So which means what I'm going to get now is, when I do that, I already did it aside. I will get x cubed minus 2x squared plus x minus x cubed, and then plus 2x minus 1 minus 1. So the final answer that I'm getting is will be x cubed, then this and this. Here is supposed to be x squared. Apologies. Yeah, this and this will give me minus 3. Minus 3x squared. So this one and this one. And then this and this will give me positive 3x. Okay. And then this one will give me minus 2. So which means this is the equation now in a standard form. Okay. X cubed minus 3x squared plus 3x minus 2. So from that equation, now you have this. Okay. So the reason I'm changing it to that is because I want to use this one because you guys are used to this one. Okay. And then now I want to find the stationary points. I want to do the stationary points. And then the stationary points, this is how you do the stationary points. We know that on the stationary point, you have to derive. And then after deriving, you have to equate the derivative to 0. Okay. So which means I can derive. So you know how to derive 3 times 1, then yeah. So which means this will be 3x squared minus 6x plus 3. Okay. And then after that, you equate the derivative to 0. Remember, we are finding the stationary point. We have to derive and equate the derivative to 0. So I have 3x squared minus 6x plus 3. And then I have 0 equal to 3x squared minus 6x plus 3. And then to get, I can see that 3 can go into 3, 3 can go into 6, 3 can go into 3. So I can divide by 3 if I want to. Or you can use the quadratic formula, it's your choice. So 0 is equal to x squared minus 3 goes how many times into 6? It goes 2 times. Okay, 3 goes how many times into 3? It goes 1 time. And then I have 0 is equal to, so you can use the quadratic formula. So because for me, I know my stuff, so I'll factorize here. And then I have x, and then the factors of 1, that when you add, they give you 2, it's 1 and 1. And then this plus tells me the sign should be the same, so it's minus, minus. Okay. So which means the answer that you are getting here, it will be 1. X minus 1 is equal to 0, or x minus 1 equal to 0. So these two are the same thing. So which means I'll just say x is equal to 1. So which means I'm getting only one x value. So x is 1. And then you have that. Okay. So yeah. So if you like, you would have used the quadratic formula here. And then you are going to get the same answer as me. And then remember, on the stationary point, you want to get the x value. For you to get the y value, we have to substitute the equation to the original one. We have to substitute this value of x back to the original equation. So which means to get y, I'll have to substitute x. So x is 1, I have 1 cubed minus 3 times 1 squared plus 3 times 1 minus 2. So which means the value of y here, it will be negative 1. Yeah, it will be negative 1. It's negative 1. So which means here I have one stationary point. The stationary points, let me write it here. Let me cancel it here. I'll write it there. So this stationary point says when x is 1, y is negative 1. So I have one stationary point. So I have 1. This one is a stationary point. Remember that it's a stationary. Let me write it here. This one is a stationary point. So normally when the graph is like this, for example, you have this stationary point and this. But then here we don't have 2. We only have something like this. You have one stationary point. Okay, you have one stationary point. Okay, so you have one stationary point in this case. So this and this are not the same. And then let us check the point of inflation. So for you to get the point of inflation, let me write it here on the space because the space is too big. So for you to get the point of inflation, let me write there the point of inflation. The point of inflation, that is where the graph changes concavity. But for you to get the point of inflation, we have to take the first derivative, which is 3x squared minus 6x plus 3. And then you have to derive it again for the second time for the point of inflation. So here I'll have 6x minus 6 here. After deriving, that is where you let the derivative be equal to 0. And then which means we have 6x minus 6. And then you can transpose 6. You will have you can transpose negative 6 to this side. So which means you'll have 6 equal to 6x. Then I can divide by 6, divide by 6. And that which means x is equal to 1. So I have the value of x here, which is equal to 1. Okay. And then for you to get the value of y of the point of inflation, you will have to take this and then you substitute it back there. You remember. So for me to get y, I will have to say where there's x, I substitute. And then minus 3 times 1 all squared plus 3 times 1 minus 2. The answer that we are going to get is negative 1. So which means here I have negative 1. So this one is a point of inflation, And then now look at this thing. What is happening here? So what is happening here is that the stationary point and the point of inflation are the same. The stationary point and the point of inflation are the same. So if you look at here, you can see that this point, which is 1 and negative 1, is the same as that one. So in this case, if the point of inflation and the stationary point are giving us the same answer, we call this point a point which is the stationary point at the same time is a point of inflection. So it's the stationary, I forgot to put stationary here. It's the stationary point of inflation. So it's the stationary point of inflation. The reason it is called a stationary point and a point of inflation, we call it a stationary point of inflation because this point that we got here is the same as this one. can you see? So that is what is happening. And then the only thing that I'm left with is to get the x and y intercepts. Ne? Let me cancel this. To get the x-intercepts, that is where you let y be equal to 0. So instead of using this equation, you see, instead of using this long one, because this one will require me to factorize, which is complicated, let me use this one. So I'll use y equal to x minus 1 cubed minus 1. Yeah. So here I want the x-intercepts. So I'll make y be equal to 0. So 0 is equal to x minus 1 all cubed minus 1. And then I'll have to transpose this one to this side. Ne? So I'll have 1 equal to x minus 1 all cubed. And then I have 1 equal to x minus 1 all cubed. And then to get rid of this cube, I can introduce the cube root here. And then here, because I've introduced this cube root, which means on this side I must introduce the cube root. So this divide that. Then on this side I'm left with x minus 1. And then the cube root of 1 is 1. Okay. Yeah. Then I can transpose this thing here. So I'll have 1 plus 1 equal to x. So which means x is equal to 2. Yeah. So which means the x-intercept says when x is 2, y is 0. We saw there. Y is 0. Okay. So that is what is happening. And then after that, we check the y. I'm done with the x-intercepts. Ne? After that, we have to check what we call the y-intercept. So the y-intercept, that is where x is equal to 0. So x is 0. And then if the equation is like this, you can just take this value as the y-intercept. You remember that. So just take negative 2. Okay. But with this equation here, you won't have to take negative 2 for the y-intercept. So the y-intercept will be equal to, where there is x, we have to put a 0. Minus 1. So with this equation, you have to do this. You don't have a choice. You have to do this. Okay? You have to do this. And then you will get this negative 2 that I got here. And then I have this. Okay? And then now I can sketch this graph and say this graph will be like this. I can start with this one, which is, remember this point and this point are the same. So when x is 1, y is negative 1. So I can put maybe 1 here and the y is negative 1 there. So which means this point maybe somewhere around here. Okay. And then x is 2. X can be 2 around here. X is 2, y is 0. X is 2, y is 0. So which means this one is here. Okay. And then this one says when x is 0, y is negative 2. So y is negative 2 somewhere around here. When x is 0, y is negative 2. So this one goes around here. Okay. See that? We know that this graph should be increasing because the value of y is 1. So this graph should do this. Okay. Yeah. So which means you have this. This one, remember this one is a stationary point. Okay. So which means this graph should turn here because this is the stationary point. It should turn here, it goes down like this. And then as much as this is the stationary point, but it is also a point of inflation. So the graph should also change the concavity after this point. So the graph should also change concavity after this point. And then to have something like this. So we can have this now. So and then we can label it here 1 and negative 1. And then this one is 0 and negative 2. And then this one is 2 and 0. So we have this graph as well. Normally these ones, they love them when you are doing what we call the supplementary exam, or you are upgrading your grade 12. You are upgrading your maths, so they will give you this one. So that is what we have. So the reason we have this kind of a graph is because the point of inflation and the stationary point are the same. So we have this point that we call the stationary point of inflation, this one. Okay. So for me, this is what I was going to do. Let me show you. I'm showing you what I was going to do with this graph. Remember the equation was saying y is equal to x minus 1 all cubed. You are allowed to do what I'm going to do here. For me, I know if the equation is written like this, I know that we have what we call the stationary point. We have what we call the stationary point of inflation. So the stationary point of inflation, this is how you get it. You do this. So you see this is x minus 1. So this inside the bracket here is x minus 1. X minus 1 I equate it to 0. And then I'll have x equal to positive 1. Like I do on the parabola when I'm taking the turning point here. So x is equal to 1, which means x is 1 here. And then to get the value of y, I just take this minus 1 as it is, I put it here. You see that? So I have what we call the stationary point of inflation. So this is the quicker way to get it. Unlike going from multiplying all up until you derive blah blah blah. So I was doing this because I wanted to use the method that you already know. This is why I was doing this. But now there was no need. So I had to do this to get the stationary point of inflation. After getting the stationary point of inflation, then I need to get the x-intercept, and then I get the y-intercept. So the x-intercept, that is where y is equal to 0. And then I will have 0 equal to x minus 1 all cubed minus 1. And then you know how to solve here. I already solved. Okay. Then I introduce the cube roots. So which means 1 is equal to x minus 1, and then 2 is equal to x. So which means x says when x is 2, y is 0. Okay. And then this is the x-intercept. To get the y-intercept, I was going to go to the equation where there is x, I put 0. And then I was going to say y is equal to 0 minus, remember I'm referring to that equation. 0 minus 1 all cubed minus 1. Which means y was going to be negative 2. I know. And then which means this one says when x is 0, y is negative 2. And then from there, you see how short are these steps. And then from there, I can draw my graph. It says when x is 1, y is negative 1. So it's this one that I'm starting with. So which means this point will be somewhere around here. Remember, I don't have the ruler, hence I'm doing this. Then you have this. And then 2 and 0 can be somewhere here. And then 0 and negative 2, 0 and negative 2 can be somewhere around here. Okay. So this graph is where the graph, remember the graph we know that is increasing. So which means this one is where the graph is the turning point of the graph. At the same time, this is where the graph changes concavity. Okay, the reason I'm using different colors is to show you here after this point or at this point, this is where the graph changes concavity. And then from increasing to increasing, from concaving down to concaving up. Yeah. So we have this. Okay. So yeah, we have that. So this is the same as what I was doing here. But here I was doing it in a longer way. Okay. Here I did it in a shorter way. So we have this graph. So I'm done. So hopefully with the sketching of graph, you cannot be confused if you watched all my videos. So you have to watch all my videos. Thank you.